to Q, that means what you are given here is original length. What is going to be the increase in length or change in length? What is going to be the value? So their change in length will be equal to what is going to be. So that is where we are going to have our value in terms of ratio. Before we do that, let's quickly go as you remember that linear expansivity is equal to change in length, original length, change in temperature. The question says they pass through the same temperature, which means temperature is what? Constant. If you are not considering temperature this time around, what are we going to have? Change in length. If this one we are not consider this, because this is constant, the same temperature. The two metals are suspended to the same temperature, so we don't need this. Okay? So let's make change in length to be equal to, then we have linear expansivity and what? Original length. Is that not what you are given? For the metal P and metal Q, their linear expansion is 2:3. Original length 3:4. They now say what is going to be the increase in length or change in length of the both metal in their ratio. It's as simple as that. Multiply, because what you are having here is this times this and this. Let's see, 2 times 3, 6. 3 times 4, 12. 6:12. This can be break down into 1:2. And that's the increase in length or change in length in their ratio of the two metals. Let's consider another new topic, and then the topic is quantity of heat or heat energy. Under this topic, the candidates should be able to differentiate between heat capacity and specific heat capacity. At the same time, the candidate should be able to determine heat capacity and specific heat capacity. At the same time, they should be able to use specific heat capacity and heat capacity to solve some numerical problems. And that is what we want to consider under this topic. The quantity of heat a body can gain or lose is given by Q mass mct. We can say that quantity of heat is directly proportional to the mass, specific heat capacity C, and the temperature change. This formula is very important. mct. Or there are some time you can have it like this, theta. Instead of T, you can have theta. Okay? So the quantity of heat a body can lose or a body can gain is equal to this. The mass of the body, specific heat capacity of the body, and the temperature change or temperature range of what? Of the body. Okay? Then if a body is now in contact with cold body, we have one body is hot, another body is cold, and we allow the two bodies to come together. One of the body will lose heat, another body will gain heat. It's as good as this. You have a hot water, you have a cold water, you mix it together. The one that is hot will lose heat because it will transfer that heat to the one that is cold. And the cold body will gain that heat and it will become what? Hot. That's what we are talking about. Okay? So, if a body is now in contact with cold body, the hot body loses heat to the cold body, but in a closed system, we will always have what we call heat loss is equal to heat gain. This one is very important. one body must lose heat, another body must gain heat. Heat loss is equal to heat gain. And generally we can have something like this. MC theta, this is temperature. Okay? In our temperature now, we will have something like this. T1 minus T3. MC, we are going to have T3 minus T2 plus, we are going to have MC T3 minus T2. This formula is telling us a situation whereby we have a calorimeter which we use to measure the amount of heat. Okay? So the calorimeter, let us assume we have a calorimeter, we have a water, you put it inside. Okay? By the time we try to pour the water maybe into a body that has a lowest temperature, one of the body must gain heat, other body must lose heat. That is a situation where we use this kind of formula. Okay? If you have question that goes with this, you are going to make use of this formula. Okay? Then we quickly go to what we call specific heat capacity. What is specific heat capacity? The amount of heat needed to raise temperature of a unit mass of a body by 1 degree Celsius. That is specific heat capacity. And the unit is joule per kilogram per Kelvin. How do we get that? From quantity of heat, which is equal to MCT. This our T is what we call specific heat capacity. Okay? So we are now defining specific heat capacity now. Let's make C the solid of the formula. Q. Then what we have? MT. The unit of Q, what is Q standing for? This is the quantity of what? Of heat. And the unit of heat is joule. This is joule. The unit of mass is kilogram. The unit of our temperature T is Kelvin. If you try to put it together, joule, this one move up per kilogram, this one move up per Kelvin. And that's the unit of specific heat capacity. And it's defined as the amount of heat needed to raise the temperature of a unit mass of a body by 1 degree Celsius. Which is the temperature. Let's take note of that. Then, we are still going to talk about heat capacity. What is heat capacity? It's the amount of heat needed to raise the temperature of a body by 1 degree Celsius. And the unit of that is joule per Kelvin. Let's look at that. Joule per Kelvin is the unit of that. So we are still calling from Q is equal to MCT. Our C is Q over MT, that's divided by MT. To be equal to the formula, we are going to have Q over T. Our MC here is what we call heat capacity. The amount of heat needed to raise the temperature of a body by 1 degree Celsius. That's why we say the unit, because the unit of heat is joule. The unit of temperature, the temperature is Kelvin. When you put it together, joule per Kelvin. Because we are having quantity of heat Q and we have temperature. Joule per Kelvin is heat capacity. Let's take note of that. Let's note this. In this case, all heat are supposed to be passed totally from body at high temperature to body at low temperature. And that's what I'm talking about. Before a body can gain heat, the temperature of that body must be low. So by the time it now gains a heat, the temperature will be high. Then the one that have the higher temperature, the temperature will be low. because it has transferred that heat to the body at low temperature. So all heat are supposed to be passed totally from body at high temperature to body at low temperature. Let's take note of that. Then we are going to solve the following question. Question number 1. Calculate the temperature change when 500 joule of heat is supplied to 100 gram of water. Specific heat capacity of water to be equal to 4,200 joule per kilogram per Kelvin. The quantity of heat Q is equal to this. We are given the value of the quantity of heat to be 500 joule. Put it there, 500. We are given the value of the mass of water to be 100 gram. But in this case, let's take it to kilogram divided by 1,000. We are given in gram, now in kilogram. Then you are converting from gram to kilogram, divided by 1,000. Then we are given the value of specific heat capacity of water, which is our C, that is 4,200. We are looking for T, that is temperature. Calculate the temperature change. 500 is equal to 1/10, 4.1. 4,200 times T. So that T will be equal to 500 all divided by 4.1 times 4,200. 500 0.1 times 4,200. That will give us 420.